welcome back. Today I'm talking about plotting using base R functions. Okay, so the first plot I'm going to talk about is a histogram. I have to put it on plot. Okay, so for this base data, I'm just going to pull 1,000 samples from a standard normal distribution, mean 0, standard deviation 1. So when I do hist, it generates a basic histogram. No frill, just the basic things we want. But of course, we're going to want some frills. Okay, so I type this. And here I am adding a label to the bottom here, the x-axis. Net word capitalization is important example of college student in thousand. Okay, and I'm going to add a label to the y-axis. Number observed. That sounds better than frequency. Okay. So here we have that x label here and y label here. That's like we intended. I'm going to go a little bit further in this next one. Main, which is the main plot title up here. I want it to say totally real histogram. Not that it is, but okay. And now we have a better bit of it. Okay. Another option we have is setting limits on the range of x and y on this plot. So xlim is the minimum and maximum values of the x-axis. So it's represented as a vector. So the first element in the vector is the minimum, the second element is the maximum. And we're going to go from -4 to +4. And similarly, for y-lim, the first element is the minimum and the second element the maximum. Okay. And it goes from -4 to 4, 0 to 250. It doesn't do that in the book, but that's simply because of the sampling differences. Okay, now we're going to make data for a scatterplot. So a histogram only is the one-dimensional plot. It's not the frequency in this one variable. And now we want to represent bivariate data. Or a unif. Min equals 0. Max equals 7. I could have just easily not specified the argument and done 100, 0, 7. And that would have been definitely fine. Oh, I need random error first. Random error. And we're going with the classic random error with mean 0, standard deviation, theta. Sigma, not theta. Okay, anyway. Okay, so what we have is a variable that doesn't depend on anything, and another variable that depends on x with some random error. And we're going to use the base R plot function, and the arguments are x comma y, what's on the x-axis, comma what's on the y-axis. This is of course an optional argument that there are with any R function. Well, a lot of R functions. I guess there are R functions with only 1 or 2 arguments, but whatever. Okay. And just like we did before, we can really build it out with optional arguments. Main reported I think it for a machine learning book it is definitely very psych heavy. I use the BFI dataset, which is a dataset from psych. My examples are extra version. Although I don't know that the examples really matter that much, like what they are. Observed. I'm going to go through and talk about what each thing's going to do. So main is going to add a heading right here. Xlab is going to change the X label to self-reported extroversion. Ylab is going to do the same thing on the y-axis. Xlim is going to restrict these values from 0 to 7, which is appropriate because our values on X were restricted from 0 to 7. And Ylim is going to restrict these values from 0 to 5. And it looks a lot cleaner in the book, but this is what you get out of it. It's a lot of dead space, there's no value between 4 and 5. But it didn't really matter that much, because this is an example. Okay? We can also add a straight line to the values using the abline function. So here we know the slope and intercept because I made the random data. You would normally want to get these values from a regression. Oh, and I messed up. Okay. Okay, that looks perfect. And okay, I'll go ahead and do that regression real quick. Okay, so the intercept is about 0.1, but it's non-significant because the estimate includes the value of 0, which makes sense because the real intercept is actually 0. And the estimate on the slope is 0.48, and the real slope that I was going for is 0.5. So 0.0, is very appropriate for this data, which I knew already because I made the data. Okay, what else do we have here? oh, a really handy type of plot called a QQ plot. And this plot is meant to show you if data is normally distributed. It's a huge assumption in statistics. And this is more useful than a histogram for determining this. Although a histogram with a superimposed normal density is quite helpful. Okay, so we have a line going from 0 to 1, and not from 0 to 1, with a y-intercept of 0 and the slope of 1. Goodness. Okay, and all these points fall along that line, with a little deviation here, but it's not very significant, and it looks normal. Okay, so let's contrast this with a heavy tail distribution. Heavy tail distribution deviate from a normal distribution QQ plot in this way. It's a little bit lower here and a little bit higher here. So let's go ahead and illustrate that. T just 10 degrees of freedom. And we do this by sampling from a t distribution, which is the RT function, in 10,000 values. And then, like I said, 10 degrees of freedom. The second argument is degrees of freedom. Okay. I did the same thing. QQ norm. And I want to put that line back on it to make it look more clear. So as you can see, it deviates here and deviates here. There's also another option you have. So I'm going to go back. QQ norm into the QQ line. Ooh, what are the arguments? But it's the same thing. It can be really embarrassing, but yeah, it looks like the same thing. The QQ line is actually more appropriate than av line. I was being a little lazy there doing av line. But QQ line is the one you should actually use. Okay? So in the book, I also make a light tail distribution. And it deviates in the opposite way. It goes down here and down here. I could... Okay, I'll go ahead and also replicate this. So light, normal, and this is not an expectation of you. I just want... It's harder to find lighter tail distribution. And I decided to make it. I do a max value of 2 for I in 1 to length. Light normal. If absolute I normal this is one case where I actually prefer the regular code writing IDE with where you save your code. This becomes a lot easier to do. Because if I hit enter to go to a new line, it's going to run my code, which is not what I want. But that's fine. I think I've done it. Okay. So let's see if my QQ norm. Yeah, that looks perfect. I have line 0, 1. Okay, and all I've done is I took the value above 2 and set them equal to 0. So everything that should be in the extreme, actually, maybe I'll do a histogram of it, and it should be more than, yep. So everything that was above or below -2, no, below -2 and above 2 was set equal to 0. The histogram looks terrible, but that's how I made a light-tailed distribution, and that's what it would look like. Okay, now we're going to go do a bar plot. So, select the bar height. Three, 4, honestly, it really doesn't matter. Okay, so I had 7 entries, so I need 7 names. Bar name. Okay, so you could do exactly what I wrote in the book, or you can do what I'm about to do. Yeah, I can't be bothered to do that again. And that gives a vector of name pasted. Participant 1, participant 2, participant 3, participant 4, and so on. Okay, so let's get the bar plot going. Bar plot. So the height of the bar is the first, and then we specify names.arg bar name, and then I'm gonna leave the ex.names alone because it might look different most right in here. Ooh, okay, so that's not good. That was a mistake. It wasn't a mistake. I just need to make it smaller to fit in the area I gave it. Brilliant. Okay, and then you see the names. Just have to have enough space to have the names. Okay. And now the last one's going to be box plot. I wish I had a fancy paste trick to get out of this, but I don't. Oh. Okay. And I'm making a response variable that absolutely does not really depend on the factory, but the bar plots don't know that. Okay. So just like I did in that regression, we're doing response distributed as a function of the factor. And I don't know why I did it, but we're going to call the column, no, the color blue. Okay. And there we are. Okay, in the next video, I'm going to get started with the advanced features of the R programming language. Okay, that's the end of the video. Thanks for watching.